All right. All right. So, good morning, everybody. Before we get started, I wanted to bring again to your attention. You guys have been, this class in particular has been doing a very amazing job at coming for tutoring. So keep up the good work. If you guys need the extra help, by all means, please come during tutoring. When is tutoring? 12:10 to 1:10, Monday, Tuesday, Thursday, Friday. And on Wednesdays, it's 12:30 to 2. And if you are doing the tutoring, click on, oh, you are so nice. My husband brought me coffee.
Love you.
Love you too. Thank you. So click on the computer and that'll send you to the Zoom link for tutoring. All right. I know it used to be on the R2D2. It's now going to be on the computer. Slowly going away. I mean, with a little splash of Star Wars still, there. But if you guys need tutoring and you can't make it to mine, click on the phone. It'll open up this. And down here at the very bottom, if you guys click on this link right here, it has the tutorings for the other math teachers. So there's Mr. Brown, not my husband Brown, but another Brown from CDA. He's now here at the CV. And Mr. Quintero. They're, depending on the day, all the times are like 2:30 to 3:45. So, and then you just have to click on their Zoom link. So that's for tutoring. A lot of you guys are catching up to your assignments. I'm sorry to see a lot of you guys, I'm checking off, like, yes, you guys are doing fantastic. Most of you guys are all caught up. So I still have a handful who I have, let's see, 1, 2, 3, 4 of you guys, 5 of you guys out of 25 that haven't turned in a single assignment. So, I mean, that's not bad. 20 out of, 25 of you guys are doing absolutely everything that I'm asking. So, woohoo, amazing job. But those 5 need to catch up because I'm going to start calling home. And especially your class, I only have 5. I'm definitely calling home with just 5 people versus the other classes is like half of them. So if you don't want me to call home, definitely start, turning in those assignments because some of you guys, the only thing you guys have turned in is the Desmos activity, and that's it. And that's not cool. I need you guys to be submitting all your stuff. Other than that, all of you guys have been doing absolutely amazing when it comes to, other than the 5 kids. So keep up the good work. We are going to be working from now until like the end of the bell. So we're going to be working a lot. The more you guys participate, the faster this goes. So if you guys stay quiet, even if it's the wrong answer, it's better than staying quiet. All right. We're going to start off with Desmos. That's where we're going to stay the majority of the day. And then we're going to switch over to our notebook. We're going to do pages 4 and 5. You do have a homework assignment. It is on Google Classroom. Some of you guys, I have 2 of you guys who have already submitted it. No, this is second period. I was like, what? And then somehow during second or first period, I went into this, and if you guys couldn't find your class, it was back in my archived again. So I don't know what's up with this class. It keeps trying to archive itself, and it's like, I don't want to work. So I had to take it out of archive again. So I don't know what's going on. So third period is like possessed or something. But you guys are going to click here. Again, I already have 2 of you guys who submitted it. Those 2 who submitted it already, you guys ended up doing a lot more questions because I decided to take away some of them. So I gave you twice as much points. So instead of it being worth 10, it's, I gave you guys 20 points versus the 10 points. But if you guys click on class kick, I'm just going to put in, D for doc. You only have 4 questions that you guys are going to have to do. This now looks all weird, but this is the formula to use for slope, to find slope. This is a backtrack to like a review of what we did last week of using the formula. And then I wrote in X1, Y1, X2, Y2, so that I can at least help you guys out with that first one. You guys do need to show me work and then put the answers right here in these blocks. All right. Other than that, then don't forget to mark it as please check. And then come back here and submit it. If you don't submit it, then I'm not going to be able to, like, I won't know that it's actually, you know, you. Give me 1 second. I'm making sure that this is actually Mr. Mickelson. Mr. Mickelson, is this actually you?
Yes, it's me, but
Yeah, that's what I thought. Yeah. So that's fun times. And it's only his account. Like, or no, his and Mr. T. It's those two teachers that, and now that's the messed up part. They have his picture. That's why I was like, oh, this must be him. Because it had, like, man, some of you guys, like, some students, why can't they put that energy into actually doing their work?
That's true.
Oh my God. So, whatever. So, let's get to actually, like, learning and not having to deal with, you know, dumb kids like that. So,
Doc,
yeah.
can I show you something?
Very,
very quick.
Yeah, like, you want to send me a message or
no, just watch my
screen? Yeah.
My profile. Yeah, just watch it. I'm gonna have this every time I'm in your class now. Look.
I don't know. Do I want to look? I'm kind of scared now.
That.
Don't forget to record.
That's a good one.
I was kind of scared. I'm like, what is she going to put up there? Oh, okay. Now, like literally, like, my heart's like beating. I'm like, what is she going to put? Oh, okay. Now I feel good. All right. So click on Desmos. It's Desmos Shading Grids Day 1. You're going to click on this. And again, if it asks you guys to, like, log in with Google. And if it doesn't, just, you know, make sure that your name is on it. Hit go. It should pause you. Remember, I can see you guys as you guys are working. So for those of you guys who just decided to, like, log in and then, like, go away, that's no bueno. I need you guys to log in. I am going to unlock you guys and start the pacing. We're going to be just on page 1 at the very beginning. Ooh, out of all of my classes, you guys have been the fastest to log in. So awesome job on you guys. So I see a lot of you guys. I see 14 of you guys out of the 26. So keep logging in. Oh, I should unpause. I restricted. I just didn't unpause. So for today, we have 5 slides. Next period, we're going to have next period. Tomorrow, we're going to have another 5 classes. I can't talk anymore. 5 slides. All right. So the direction says, examine the patterns below and write the number of colored rectangles in each grid. Continue the patterns in stages 4 and 5. So I'm going to look at pattern A. Notice right here, I do have a circle. I can click on that and change the colors. So I'm going to click on A, or like red for A, because it's in red. If you can't change the colors, it's no big deal, guys. Just do the best you guys can. And it says to count it. Oh my God. By the way, Isaac, are you here?
Me?
Yeah.
Yeah.
Okay, making sure because someone's trying to log in as you.
Really?
Yeah,
Again?
yeah. And it's only
That's
in
a-
this class. Fur, is this actually you or Fed?
Yeah, it's actually me.
Okay, just making sure. Only this class. I don't know. They really want to be in my class, guys. I'm just that popular. You know, it is what it is. So we're going to count 1, 2, super hard, right? And then we're going to write the number 2. Count again. 1, 2, 3, 4. So 4. 1, 2, 3, 4, 5, 6. 6. What you guys need to do is continue the pattern. So you're still going to be coloring them in on 4 and 5, and then you're going to write the numbers on the top. Same thing goes for the ones in blue. I would probably switch my color to blue, count 1, 2, and then keep going from there. That's all you have to do. Again, you're looking for a pattern. What did they do to go from 1 to 2, 2 to 3, 3 to 4, 4 to 5? All right, I'm going to give you guys 5 minutes. Look, I found a new one.
Oh, I like that one.
I like this one better. So you guys have about 5 minutes. So again, Miss Gomez and I can actually see what you guys are writing as you guys are writing it. We can see how you guys are drawing things, the way you guys are thinking. So great job. Does it have to be like super colored in? No, you can just draw a straight line like this, like I did. It doesn't have to be super filled in like these are, because that takes up too much time. But a lot of you guys are getting all of A down correct.
Mm-hmm.
Make sure you guys are actually counting on B. A and B are not going to be identical. Similar, not identical. They're not twins, they're siblings. Ooh, Jonathan.
Yeah.
Good job.
Okay.
Jessica, good job.
Yes.
Some of you guys are catching on to it pretty quickly. Ooh. Manuel, the pattern that you have is great from 2 to 5, but does that pattern still work from 1 to 2? Man, I'm just like super popular today. I have a D shunt. And if you put that together, it's something inappropriate. Yeah, you just have to laugh at all of those. Like, it's just hilarious. All right, guys. You have 2 minutes. For the most part, I'm seeing all of you guys. Anthony, I see it. Great. See, now I feel like it's one of you guys because I've been laughing at all of these dumb names. And they wouldn't know that I was laughing at all of these names if it wasn't for you guys.
True. Mm-hmm.
Duck. Yeah, I get it. Oh, let me see. Your numbers are so tiny. Oh, no. your pattern for 8, your pattern that you picked goes great for 3, like 3 to 4 and 4 to 5, but not for 1 to 2 and 2 to 3.
Remember, they're different patterns. So what pattern you found for A won't work for pattern B. Although they're similar.
Doc, can you check mine, please?
Yes. No, so some of you guys are having issues and some of you guys are drawing the colors and it's a little bit off. So, here, let's talk about, yeah, a lot of you guys are starting to ask like, oh, how's mine? How's mine? Let's do this together and we'll work on it. So all of you guys got A correct. You got 2 to 4, 4 to 6. Oh, I'm like, what was that sound? Oh, my timer went off. I need a restart to this period.
It's been
Alright.
a while, right, already.
Yeah, all right. And it's always the one that I record. That's not cool. All right. 2 to 4, 4 to 6. What's gonna be number 4? What's gonna be my 4th step?
8.
8. All right, cool. So I'm gonna have 8. What about for 5?
10.
10. All right. Can anyone tell me the pattern? What's the rule? What am I doing each and every time?
Going up by 2?
Go-
No.
Adding 2.
So we're adding by 2. I'm looking, that's a key word right there, adding by 2 versus just counting by 2. So adding by 2 each time, because some people might not know what counting by 2 means. So we know, everyone knows adding by 2. Everyone's good with that. So add by 2. And then, oh, I don't need that one. I was like, I pressed, okay, whatever. I'm done. What about here? I have 2, 1, 2, 3, 4, 4. A lot of you guys just decided not to count and just put a 6. But if you count 1, 2, 3, 4, 5, 6, 7, 8. So you might think, okay, it's gonna be the same pattern. 2 plus 2 is 4. Cool. But 4 plus 2 is not 8. So what could we do to 4 to get 8?
You times by 2.
Multiply by 2 or times by 2. Yeah.
Get it, dog.
Ah.
You get it now? A lot of you guys are like, oh, okay. So yeah, so some of you guys were catching on and saw something here. Like some of you guys were adding 4. So you were adding 4 and adding 4, but adding 4 wouldn't work for these two. If 2 plus 4 wouldn't give me 4. So the only one that works is to multiply by 2. This one again, multiply by 2. So then I would multiply by 2 here. What's 2 times 8?
16.
16. So I'm gonna do the 4 that were already here, and then I'm gonna double that. So this is 16. What's 16 times 2?
32.
32. So I would have 4 lines going. All right. So I'm gonna open up the next slide. And it says, describe some similarities and some differences about the two shading patterns. So you're gonna go back and kind of tell me 1 or 2 sentences. Tell me, what do you notice that's the same about all the red versus the blue? or what do you notice that are different between the two? So a similarity and a difference. So technically 2 sentences or one with an and. So again, start writing, like, what do you notice? So a lot of you guys, I like what I'm seeing.
Yeah, very
You're on
good.
the right track.
Mm-hmm.
It doesn't have to be like rocket science or anything like that. It could be super simple.
You guys are doing pretty good on your responses.
Mm-hmm.
You guys picked up on the very important pieces here.
Doc, for each row in square, does it have 10?
Yes, these are all
10.
10, 10, 10, 10, 10, 10 for both of them.
Okay.
Oh, it's 10 by 10. So yeah, does anyone want to tell me, like, all of you guys are right. So does anyone want to tell me one of your similarities and one of your differences? Or someone want to tell me something that they saw that was similar? Or a difference? Not both. You don't have to tell me both. All of you guys are right.
The similarity they have is that they both go by 2.
Yes, the similarity is that there's a 2 involved in some form or another. You know, this one, this one has a 2, this one has a 2. They're both going in some form or another by a 2. Okay, so that is a similarity. Can anyone tell me a difference? What is different between the red pattern and the blue
The
pattern?
difference is that the red one is going by 2, and the blue one is that we're multiplying by 2.
So yeah, the red one is we're adding 2 each and every time. So adding is our key word. And then the second one, our B, is that we're multiplying. Again, multiplying is our key word. So multiplying by 2. So even, you could have gone something as simple as, well, this one's red and that one's blue. Super easy. Whenever we're asking you guys to go we'd love to see you guys go that one step farther, but any answer is better than nothing.
Mhm.
All right. I'm going to open up slide 3. You're going to have to go back to slide 1 to pull all of these numbers. But what you're going to do in slide 3 is all the numbers for pattern 1 or pattern A, the red one, are going to be written down here. So just like we had before, it'll be 2, 4, 6, 8, 10. And we see all of our dots right here. You're going to do the exact same thing for the blue. You don't have to go past what you guys already did. So you don't have to do like 6 through 10 through 100. Just do 1 through 5. It'll only fit on here anyways. Red I already did for you guys. Now I'm going to ask, see if you guys can try it. You don't have to, but it would be nice to see who can, catch it. What would be our equation for either the red one or the blue one would be down here at the bottom? Do you have to do that part? No. All I really care about is the table. But if you want to take a chance and try it out, try out the equation part. It could be something like this. See how my line shows up, but it should line up with these dots. So you guys can mess around with the numbers and figure out which one would work. But again, you don't have, oops, And if you do this like I did, you press the house and it makes it back the way it was.
So we can write any number?
No, the numbers are from slide 1. So
Oh.
2, 4, 6, 8, 10, 2, 4, 8, 16, 32. Those are the ones, you'll put the red ones up here in the red box, in the underneath the red one, and then the blue one is on the bottom.
2, 4, 6, 8, 10, right? Yep.
Yeah.
And then the blue one, where's the blue one?
The blue one's towards the bottom.
2, 4, 8, 16, and 32. Okay. there we
Ooh,
go.
some of you guys are starting with the blue versus the red. Everyone else has gone like always red first.
Yeah, that's true.
Do we have to write an expression?
If you want to try it out, you guys can. And I'm going to open up the next slide as well. Some of you guys are already finishing, and it kind of goes along with it. So slide 4 says, describe what you notice about the similarities and differences in the rate of change. That's the pattern, the rule between the two patterns. Be sure to comment on how the numbers are changing. Be sure to comment on how the graph is changing. And if you want to focus on how the graph looks, that's totally fine. Give me a sentence of how you're seeing that the graph is changing between the red dots and the blue dots. So some of you guys, you guys can see a dramatic change. Others, Alfonso, I think you put the same numbers on both the red and the blue, because they're on top of each other. They should only be sharing these first two, right? Because in our table, in our pictures, they both had 2 and 4. So both of those should be blue, or technically it would be purple if they actually would blend the colors, because both of them are the same. But after that, they should be different. But again, tell me what you're noticing about the red dots versus the blue dots. Anything that you guys can tell me. Ooh, Jessica, yes. Ooh, Cassie, yes, I like that.
We're like this or in chat?
Huh?
Can we tell you like tell you or we do it in chat?
Oh no, we're putting it here on slide
Oh.
4.
Okay.
Good
Yeah.
question. We're getting some good answers here.
Yeah, I like it. So I really like the fact that you guys are comparing them. So a lot of you guys are starting to talk. So I'm going to start putting in those extra dots. So 2, 4, 8, 16, 32. So your dots should look like this. The first 2, technically purple, but they look like blue because they are, because Desmos doesn't know how about color blending. What can you tell me about the red dots versus the blue dots? What's going on? Now I'm asking for you guys to unmute yourself or put it in chat, one of the two. What can you guys tell me about the red dots versus the blue dots?
I could tell you that the reds, they go all like in a line, kind of. Not like a line, but they're all like
Yeah,
matched up.
Straight line.
Does not go at all. It goes and then it just goes all the way up. Like they're not matched up. There's no pattern.
there's a pattern, but not not the way that we're used to seeing
Not a
it.
pattern, they're all together, I mean. Like
Yeah, yeah. So all of you guys are in agreement that this is a straight line. If you guys were trying the equation, which I don't think anyone actually did in this class. I think Jessica started to, but for the most part, you guys were like, no, I have other things to do. So when we're looking at the equation here, remember we had that, we were going off by, yeah, blue is zooming. Yeah, it is. If we look at our equation for our line, it looks like this. It has a 2x. It's starting at 0, 0, so I'm not going to have a y-intercept. However, for this blue line, this is where we're heading towards. So we've been talking about straight lines for the last 2 weeks. Now we're going to be talking about a curved graph. Those curved graphs are called exponential functions. And exponential functions look like this. It looks like a curve. So if I zoom out and move this, it'll look like a curve versus a straight line. So when we're dealing with exponential functions, and no, do you have to write these expressions down? No, you don't. But if you want to make this exponent, you have, if you go to your key bar and you look at 6, it looks like a little like pyramid, like a little triangle. It's called a caret. If you click on that and then hit the X, it'll make the exponent. But obviously a line is going to look like this, 2x plus something, while an exponential function is going to obviously have an exponent because it's called an exponential function. Kind of goes together. All right, let me open up that last slide for you guys. And these are all the numbers that we got from slide 1. So all of these that we had in slide 1, now I'm putting it as a table. So I want you guys to, again, we're going to color coordinate them. And you're going to follow along with what they wrote. So you're going to draw your little arrows. And you're going to say, what did we do? We added 2. We added 2. We added 2. We added 2. Change this to blue. What did we do here for each and every one of these? All right. They started it. Now you finish it. And you guys can give me a sentence. What is the key word for linear functions? What is the key word for exponential functions? Yeah, I know. I'm so restart. That's what I need. Restart for this day. That's it. I'm done. So you're gonna not just give me the word, but you're gonna give me a sentence. But I kept saying like, oh, think of your key word whenever we're dealing with linear functions versus exponential functions. I mentioned both of the words that will give you guys the answers to these sentences, or for this sentence and this sentence. So explain in a clear sentence how a linear function grows and how an exponential function grows. So that is your last step. So again, think about what are we doing each and every time, and don't use numbers. Just use the keyword. But that should give you a hint about what we should be talking about in those sentences.
Ooh, good job, Jonathan.
So a lot of you guys are heading in the right direction.
Good job, Manuel.
Doc,
Yeah.
can you go back to slide 3, please? Just real quick.
3, yes. And Fed, you're like too much, man.
Please go down, please.
Scroll down. Oh, this, yeah.
Oh, okay, thank you.
Yeah.
Wait, how did I put 2x squared?
So you don't have to put this part, but if you put, see, I can't, let me draw it. It looks, you would write it like this. So you would, I can't write it there. It's 2, and then there's a caret, and then you would write the X.
Oh,
There, it's on top of your 6 key.
okay,
So you have to do shift and then the little pyramid caret guy.
okay. Thank you.
Mm-hmm. So what can you guys tell me? What are we doing each and every time in this guy? In the first pattern that we have, what are we doing each and every time?
Adding 2.
We're adding 2. So that's actually going to be our pattern for linear functions is that linear functions. Oh wait, I'm not supposed to be typing this. So we're talking about I'm already so you're telling me linear functions, they're growing by addition. So it's not necessarily always by 2, because it could be by 3, by 4, by 10, by, you know, some other number, but it's always going to be growing by addition. So addition, adding is our key word here. So it grows by addition. What about for exponential? How does that one grow? What are we doing each and every time?
Multiplying.
Yeah. So exponential functions, it grows by multiplication. So each and every time we are doing anything from one step to the next, we are multiplying it. So that's it. Once you guys are done with this, come to your Google Classroom. Please make sure to submit it, mark it as done. If you don't do that, you don't get the points. So make sure that you guys come here and mark it as done. I see who has already participated, but still, I need to see your guys, you guys actually going in and marking it as done. Once you've done that, again, you guys do have your homework assignment. No, we are not done. We are going to be working on our notebook. Today's Thursday, so we're going to be doing pages 4 and 5. Again, restart for today. It's just done.
There you go.
So we're going to do pages 4 and 5. Please make sure to, click on Classic. Please make sure to be logging in. Some of you guys are still not logging in, but I'm going to stop sharing because Miss Gomez is the one that's actually going to teach you your notes today.
I'm taking over only for the last half of the last 30 minutes actually. All right.
And
Slides 4 and 5, page 4 and
Okay.
5. So I'm going to join you guys on ClassKick here.
Did we do 3?
Yes, we did that yesterday. We did 1, 2, and 3 yesterday.
Yesterday was Wednesday, Doc.
Tuesday, you know what I'm talking about. And if you guys didn't catch it, I think I haven't put up the YouTube link. Yeah, I haven't because this is blank. So I will make sure to do that today too, because I'll put in this one today. So today you'll get 2 YouTube links, one from Tuesday and then one for today. Sorry about that.
Okay, give me a thumbs up if you guys can see ClassKick here because it usually shows me in a green box. It's sharing, but okay, good. Thank you.
Yes, we can.
All right, so this is where we'll be taking our notes for our linear versus exponential. And just like your Desmos activity, we're still looking at tables, okay? We're just trying to go about one step further, really. But you guys did really, really good with your Desmos activity. Okay, and you got to see a glimpse of how linear functions and exponential functions behave, and that they're different. There's some similarities, but there's a big difference between the patterns you saw. So just to summarize what you guys found, you guys said that those red dots that formed a straight line, those were growing by an adding pattern. Okay, and that's a really good observation. We want to stick with that. You guys also noticed that the blue dots were growing by a multiplication pattern. Okay, so you want to keep those patterns in mind, because that's what we're going to be talking about, but we're going to take it just one more step further and give you some vocabulary for today. So I'm going to open up the presentation here. Okay, so for today, we're talking about the increasing linear. So increasing just means we're going up, we're getting bigger, versus the increasing exponential. We have a straight line here because of linear, but the exponential was doing something different, which was a curve. You guys got a glimpse of those things there. Okay, so we'll start off with today's objective in the I can section here. Let me get my laser. So in the I can, so your objective for today is that you should be able to identify, so find an increasing linear or find an increasing exponential function. So if you have a table, you should be able to tell the difference, and you should be able to find some features from those tables. Two things, so 2 steps. But we'll start off with your increasing linear function. So that was your red dots. When we put your red dots in the Desmos activity, you notice that they were going up. And if those of you that came up with the equation were able to see that it formed a straight line. So those dots, when we connected them with the equation, we got a straight line. Okay, so when we were talking about linear, just remember the word linear has the word line in it. So we're looking at a straight line. Okay, but we're interested in what's going on in a table. So we're interested in finding a pattern. So that's going to be your first step when you're working with these tables and you're trying to decide, is this linear or is this exponential? You want to find your pattern. Okay, on the X side, there isn't a lot going on. This is just skip counting by 1. So we're just adding 1 each time. And that's good. When these tables are just skip counting by 1 on the X, that's good. We can find a pattern more easily. And for the most part, we're going to be giving you tables like this. But the pattern we're really interested in is the Y pattern. So whatever's going on in your Y values. So you have a 3 first and then a 6. So what pattern's going on that takes us from 3 to 6?
Adding.
Ooh, good job. From 6 to 9 and 9 to 12. Now I heard adding, but can someone tell me what exactly are we adding each time?
Adding by 3.
Good job. Perfect. For those of you that weren't quite sure, 3 plus 3 gets us 6. 3 gets us 9. And 9 plus 3 gets us 12. Okay, so the important part is that it is consistent. It's the same number adding over and over again. So plus 3 each time. So when you're looking at a linear function that's increasing, we notice an addition pattern. And that's going to be your first step when we're working with these. And this first step is going to continue on for the next days, okay? So it's all about finding your pattern. Okay. So those were your red dots on the Desmos activity. We're going to look at your blue dots, your blue grids. We're going to look at the increasing exponential. So when that exponential or the grids were increasing, we got a curve. I didn't see you guys use the word curve, but I did hear somebody say it's doing something different, something that's not a straight line. And that's true, it's not a straight line. So that's something you want to recognize. When you put your points it's still going up, but it's not going up in a straight line. We're getting a curve. Okay, so we have a table here on the left side. First thing you want to do again is find a pattern. So as we look at our X values here, these are going up by 1, so we're good here. Again, that's not the most important part, but when they're going up by 1, it's easier to find the pattern. What we're really interested in is finding your Y pattern. So take a look at that 3. What can we do to that 3 to get us to the 9? From there, what can we do to get to the 27 and so on? Go ahead.
Multiply by 3.
Yes, good job. Yeah. Here's one thing that I will point out, because some of the other periods tried this, and it's okay if you tried it and you didn't get the correct answer the first time. Somebody said, can we add? Well, 3 plus 6 gets us 9, but that is not the case here. 9 plus 6 is not 27. That's 9 plus 18. It's not the same pattern, so we can't go by that. So it's okay if you tried addition first, okay? But when you realize it doesn't work, we gotta try something different. And thank you, girls, for those of you that gave me, we're multiplying by 3 each time. 3 times 3 gets us 9. 9 times 3 gets us 27. And then 27 times 3 is 81. Okay, so when you look at these tables, they look similar. This has a 3 to start with, and this has a 3 as well. What changes is our second value here. We have a 6 and a 9. So the linear function that's increasing has an addition pattern. But looking at the exponential function, we saw the multiplication pattern. Okay, so they look similar, just like you saw in your Desmos activity, but the patterns are different, and that's what we're really trying to focus on. Okay, I'm gonna go over to your Classkick notes, and we're just gonna drag those little pieces over. We'll take your objective. We're trying to find linear or exponential functions. And we looked at the increasing linear. We saw that's a straight line that's going up. If we were to take these points and put them on the graph, you'd still see that straight line going up. What we want to do, the first thing, oops, where is it? Is find the pattern. We notice we go up by 3 each time on the Y's. So that is an addition pattern. When we're looking at the next table, that's going to be an increasing exponential. And it has a curve. When we're looking at that table, we found it has a multiplication pattern. So that's what it should look like right now. If you're on Zoom and you're not and it's not working out with having Classkick on at the same time, that's okay. We can get a screenshot after we're done. But if you're okay to move on to the next slide, give me a thumbs up. If you need some more time, give me a clap.
I did the whole page.
Ooh, good job. Okay, I didn't see any claps. So we're gonna go back to our presentation and see, well, what's the point of finding these patterns? Okay. The patterns let us know the difference. One is linear, one is exponential. If we're adding, that's linear. If we're multiplying, that's exponential. But these patterns give us something much, much more that we're gonna need in the future. And that's this second part here. So you guys have seen these words already in that Desmos activity. On the linear side, so I'm looking over here. On the linear side, when you see that addition pattern, you have found the rate of change. The rate in which these numbers are changing, but we also call it the slope. So for those of you that this was your first time hearing rate of change, you've actually been finding rate of change when you find slope. So it's the same thing. So in this case, on the linear table, our pattern was to add by 3 each time. By finding that pattern, you found your slope, your rate of change. Our rate of change here is or our slope is just a positive 3. We're going up by 3 each time. Okay, so now on the other side, on the exponential side, our multiplication pattern has a different name. We call it the constant multiplier. Okay, the word constant means to do something over and over again. The word multiplier has the word multiply in it. So we're constantly multiplying something. That's our pattern. So on the exponential side here, when we were looking at 3, 9, 27, and 81, our pattern was to multiply by 3. So that is actually our constant multiplier. That's what we call the constant multiplier. So again, the pattern gives you so much information. You found the rate of change if it's a linear function. You found the constant multiplier if we're looking at multiplication over and over again. Okay, we're gonna go over to your notes. Drag that adding by 3 as your rate of change. So on our linear side, if we're adding by 3, our slope is positive 3. On the exponential side, if we're multiplying by 3 over and over again, our constant multiplier is to multiply by 3. You could just write a 3. The dot's not there. I just put it there for you guys to know that that's multiplication instead of adding. We're just multiplying by 3 every time. So this is what you should have right now.
Is there supposed to be multiplying and subtracting 3s?
Say that again?
In the slide, is there supposed to be dividing by 3 and subtracting by 3?
Oh, these that you see over here? Not
Yeah.
yet. And you're going a little ahead, but yeah, we're gonna get there. It's gonna be in there. You'll see
Slow
why.
down. God.
Oops. Sneaky dog.
Okay, give me a thumbs up if we can go back to our slides, or if you give me a clap if you need more time to drag some of those pieces. So again, the activity showed you how to find the rate of change, your adding pattern, but it also taught you how to find a constant multiplier if you have a multiplication pattern. Okay, I got thumbs up. So we're going to go back to our presentation here. So that's your first step. Remember I told you guys there's 2 steps. The first step is to find your pattern. That tells you if it's linear or exponential. And if we have a rate, I mean a slope, or if you have a constant multiplier. The second step is also something you should be familiar with, but we're gonna give it a different name. Same thing, but different name. You need to find the initial value. Your initial value is actually the same thing as your y-intercept. We're just calling it a little differently, but same thing. And the word initial, so initial here, that's usually like the starting point, okay? And there's a reason why in our table here, there's a blank spot, okay? The reason why there's a blank spot there is because that's where we can find our y-intercept. To find your y-intercept, we're still using the pattern. So see how important this pattern has become. It's helped us find 2 things. We're going to be using our pattern to work backwards and find where x is 0. Okay, so we know that our y-intercept is at x is 0. So from this one, we have to work backwards this way, which means we just subtract 1 and that gets us at 0. I have no idea why that extra piece shows up ahead of time. I tried fixing that, but it wouldn't. Okay, so see, we're working backwards because we want our y-intercept. And we only get that when we have this 0 up here. So just like we work backwards on the x side, we have to work backwards on the y side. But you use your pattern. Okay, so we found that our pattern was to add 3 each time. Okay, if we want to find the value on top here, we go backwards. So what do you guys think we have to do to find that missing number here?
Subtract.
Yeah, good job. We're subtracting. And if in this case we were adding by 3, this time we're going to subtract by what number?
3.
Good job. So this time, if I click over here, there we go. We subtract by 3. So what you want to do is think of 3 minus 3. What does that give us?
0.
Good. 0. And you just found your y-intercept by going backwards. So 2 steps. Find your pattern. It'll tell you if it's linear or exponential. Second step, use your pattern to go backwards and you find your y-intercept. So we found that our y-intercept is at 0, 0. Or, and this is written as a point, okay? There's times where we'll need it as a point, and then there's time where we just need it as the y-intercept is 0. It's the y value here. Okay, so that's how we use an adding pattern to go backwards to find the initial value. We should be able to do the same with an exponential table. So remember your table on the exponential side here. We said our pattern is to multiply by 3 each time. If we want to find the initial value, we have to do the same. We have to go backwards. So if we go backwards on the x side, it gives us the 0 we need there. What do you guys think we have to do to go backwards to that top number here? And think of your pattern. It was times 3 here each time. If we want to go back, what do you guys think we can do? Or if we want to go in the opposite direction, what would it mean to do the opposite?
Subtract.
Okay. Let's think about it this way. When we have addition, the opposite is to subtract. So when we had +3 here, we had to go back by subtracting 3. When we have multiplication, what is the opposite?
Division.
Good job. It's division. So if we want to go one step back, we are going to need to divide by 3. So that means we'll take this 3 and divide it by 3 to give us this number here. So what is 3 divided by 3?
1.
Good job. So that is our y-intercept. We're working backwards means we are going opposite. Okay, but we can only go in the opposite direction if you found your pattern to begin with. So that pattern is everything. Okay, so our y-intercept is 0, 1. Or we could say the y-intercept is at 1 because we're focused on this one here. All right, we're gonna go on over to our class kick notes. We're gonna drag some of these pieces on here. When we are looking at the initial value, when we are trying to find the y-intercept, we can only do that when x is 0. That means that when our table here on the top, we should need a 0. So we need to go backwards using our pattern. To go backwards from adding 3, we need to subtract 3. That's why there was that subtract 3 here. We only subtract in these here with when we have the adding pattern when we're going backwards. When we go backwards, we got that 3 minus 3 is 0. And that gave us our y-intercept 0, 0. So you want to drag that 0, 0 over there. So we're pretty much done on the linear side. Okay, we found that when we have an adding pattern, that is linear. It gives us the rate of change or the slope. And that pattern can also give us the y-intercept if we go backwards. Okay, on the exponential side, we're going to drag those pieces that are left. I'm going to put them up closer. Same thing. If we want to find the y-intercept, we need to use that pattern and go backwards in our table. Well, if we were multiplying by 3 to go backwards, or if you want to say opposite, to do the opposite, you can divide by 3. That's how we got the point 0, 1, because 3 divided by 3 is 1. So we go ahead and grab our y-intercept. Our y-intercept is at 0, 1, or you can just say the y-intercept is at 1. I can't get the full page here, so for those of you that were not able to follow along with this because of connection issues, I'll let you take a screenshot now of this section, and then I'll scroll down so you can get the screenshot of the second section there. Okay, I'm going to scroll down for the last section there. So 2 steps, boys and girls. I want to put a lot of stress on that it's 2 steps because we're going to be focusing on these 2 steps for the next coming days, I think up until next week. And that first step, finding the pattern, gives you all of the information we need, the rate of change. And we can use the rate of change or the constant multiplier to go backwards. Okay, give me a thumbs up if you're okay with this page, if you got your screenshot or if you dragged everything. If you need some more time, you can give me a clap. Okay. So we're running short on time today, so we're only going to have time to cover 1 problem of the your turn. So go ahead and go to page 5 or slide 5 of your class kick notes, where it says linear versus exponential your turn. And we're looking at tables again, trying to find out if we have a linear function or an exponential function. So we're trying to find those patterns. If you have a linear function, then you want to know what the constant rate of change is. Just your pattern. It's another word for pattern. Remember that. If you have an exponential function, tell me what that constant multiplier is. So I gave some of you a hint. Well, not some of you. I gave you all of you a hint here. There are 2 exponential functions here out of the 3. 2 of these are going to be exponential, and only one of them is going to be linear. Okay, we're going to work through the first one together. I think that's all we'll have time for. And the last 2 will be assigned as homework. Okay, we have a table. You want to start. The first step was to find your pattern. So I'll give you guys a couple of seconds to see if you can come up with a pattern for your y's. So take a look at your 6, the 12, the 24, and the 48. When you have found the pattern, you can unmute yourself or you can type it in the chat.
It's 0, 0.
Oh,
Oh, no.
the
So
pattern
the pattern is +6.
+6. Okay, let's take a look. So remember, you want to make sure that this pattern is consistent, that it's the same pattern over and over again. So if we add 6, we do
Multiply.
get
It's multiplied by 6.
multiply. Okay. So let me just show them why it wouldn't be add by 6. 12 plus 6 does not get us 24. So good catch after you guys said that. Good catch.
Wait, no, it's multiplied by 2.
Good job. Good. It doesn't, if you're trying a couple times, it's okay. You're not going to get it on the first time. That's totally fine. What matters is that you're trying to find something that works. So 6 times 2 gets us 12. 12 times 2 gets us 24. And 24 times 2 is 48. Now that you found your pattern, it should tell you if it's linear or exponential. So in the chat, you guys can type in L for linear or type E for exponential for this table. What do you guys think? L, is it linear? E, is it exponential? Yes, good job. This is exponential. We talked about that. A multiplication pattern is exponential. Good. Okay. Remember, that pattern tells us it is a constant rate of change or constant multiplier. So which one do you guys think belongs to this pattern? Do we call it a rate of change or do we call it a multiplier? I'll make this easy for you guys. If you want to type in S for slope, you can say S for rate of change, or you can just give me M for multiplier. Oh, I like what Jessica did, CM, I like that. Yes, perfect, good job. This is a constant multiplier. And our constant multiplier is our pattern, which we said is 2. Remember, your pattern gives you everything we need here. The constant multiplier of 2. Good. We're at the second step. This is your second step. To go backwards, use your pattern to go backwards to find that initial value. Good. Okay. So if our pattern was to multiply by 2, to go backwards means we're going to have to do what?
Divide.
Yes, perfect. Divide by 2. So 6 divided by 2 is?
3.
Good job. And this should be 0. So we get that our initial value, our y-intercept, is at 0, 3. So 2 steps, but it all starts with your pattern. And a couple vocabulary words there that we want you to know: linear, exponential, constant rate of change or constant multiplier, and initial value. Okay, give me a thumbs up if you guys are okay with that problem there. Give me a clap if you need a little more time. Okay, all right, I know your lunchtime is in about 2 minutes, so you're gonna want to do the exact same thing for the last 2 here, okay? Find your pattern, that's your first step, and that should help you decide linear or exponential. Is that a constant rate of change or a constant multiplier? And second step, work backwards to find these 2 here for your initial value. And then go ahead and type in a reflection there. And you can go ahead and click on the please check, I believe, on the little hand. When you're done with those, click please check. If you finished your notes here, you can also go to please check to make sure you let us know that you're done. All right, I'm going to stop sharing this here. And I'm going to let Doc Brown take over.
Hey guys, so some of you guys at the end were saying like you guys are having Wi-Fi issues. Again, it's fine. You'll have the recording. You guys can just like fast forward it up to the point where, you know, you see the parts that you were missing, and you can just watch that and then just move the pieces where you guys need it. I will have this video up for you guys a little later today. Or you guys can come during tutoring. We can show you guys real quick, you know, what the end of it was. You guys did fantastic. I know you guys have 1 more minute before the class is over. Your exit ticket should be out. So even though it it'll show off probably that it's late, I don't care. Don't worry about it. Just submit it. It's totally fine. But you guys did fantastic. So good job. And we will see you guys tomorrow, and tomorrow is going to be very similar to what we did today. It's the exact same format.
Doc,
Yeah.
is there an exit ticket or no?
Yeah. So refresh